Fluid work. This is the fluid system. I'm talking about work. All right, remember what your fluids are. They're liquids and gases. The prime mover for fluids, all right, is pressure difference. All right, and this is what causes liquids or gases to move, or so that work can be done. Studying weather is probably like the best example of where you're going to have pressure difference. And here I have pictures of a couple major things. We have our hurricanes here, all right, and you can actually see the eyes of these three hurricanes. Looks pretty cool. What causes those is actually pressure difference. Here we have a tornado. you got some extreme pressure differences there. But even like wind, what causes wind? You talk about watching the weather. And they say, oh, we have a low pressure coming in or a high pressure coming in. Right at those boundaries are generally where you're going to get your wind. For example, you're a hot summer day, and they say that there's a low pressure coming in. And you can see it, you can feel that the air is starting to move, and you're starting to get that pressure difference. You're getting wind. Okay, so you experience that all the time. All right, some of the terms that we want to look at here are open versus closed systems. A closed system is when the fluid is retained and recirculated. The circulatory system would be an example. Your heart is a pump. That's why I have a picture of it right here. Your heart is a pump, and it pumps that blood to all parts of your body, and it comes back in, all right, and it's pumped again. And you find that with this picture that I have here, you have a fountain. Well, they do the same thing. That water is recirculated. Okay, usually it's filtered, and in the circulatory system, our kidneys are the filters. But it's filtered and it's put back into the fountain. Now, if you want to look at a really big picture, you think of the water cycle. It rains, and that water either goes to be surface area like ponds and streams, or it becomes groundwater. And if you have a well, all right, let's say you're planning on watering your garden, you're going to have that garden hose, and you're going to, water your garden. Some of that is going to evaporate, and it's going to go up into the atmosphere. And what happens? It comes down as rain. Okay, and I have here a cooling system in a car. All right, with that, basically your cool air is coming into the car. Now that's provided that you're not opening your windows, okay? But it's recycled, okay, within the car. Refrigerator does the same thing. And we have our pond in the foyer, or not really a fountain, but more of a pond with our fish. That works the same way as the fountain here. We have a big pump, and we have filters, and it filters the pond water. Okay, otherwise you get pretty yucky. All right, that's considered a closed system. Now, what about an open system? It's a one-time use. Things that would have an open system, like a fire hydrant. The firemen open that fire hydrant and they put out the flames of a burning home. All right, they don't collect that water. Like, that water just seeps into the ground. One-time use. A shower. Now, some places, some people are very good. They have what they call a greenhouse, and by green home or house, what I'm talking about is you actually could catch that shower water and you could filter it and you could use it again. All right, most people don't do that. All right, so because of that, typically showers are going to be an open system. One-time use, it goes right out to either your septic system or to the public sewer. Bleeding ulcers, same way. It's basically a hole in that circulatory system. You can bleed out, you can die from that. Gunshot wound, same thing. Spray can, you're spraying. All right, one-time use. All right, now the equation that we're going to use is work equals pressure times volume. Now, one of the things that I don't have in here that is kind of understood is that either pressure or volume is going to remain constant, and the other one is going to change. Okay, and what you're going to see in these problems is that that change has already occurred, and you are seeing the difference. Okay, whether it's pressure difference or volume difference, you are seeing that change. Now, W is going to be for work, capital P for pressure, capital V for volume, just like we've seen before. Now, if you have trouble with rearranging things, all right, here's the pyramid that you can use to help you. W goes on top, P's on the bottom, V's on the bottom. So it's work equals P times V. If I want to solve for V, it's going to be W divided by P. If I want P, it's W divided by V. All right, and one little note here. All right, either pressure or volume is changed for work to be done. I had mentioned that. And I'm not sure why I have that statement. If either changes, then no work is done. You got to have, something has to change. If something doesn't change, there is no work. I think that's what I was going for there. Okay, we talked about the variables. How about the units? With work, inch pound or foot pound. All right, and if you're using that, if you want inch pounds, you're going to be using PSIs, which is a very common unit. And if you're going to do that, then your volume has to be in cubic inches. Remember, this is a 3 here, or cubic, because it's volume, which is length times width times height. Okay, now if you were using foot pound, you'd have to use pound per square foot. And that means that your volume would have to be measured in cubic feet. Now in the SI system, you've got Newton meters, which equals a joule. Your pressure would have to be in newtons per square meter, and your volume in cubic meters. Here's an example. Let's do some problems here. A pump doing work at a constant pressure of 10 pounds per square foot moves 2,500 cubic feet of water. How much work is done in moving the water? Well, the first thing you need to do is you need to look at the problem, and you need to assess what you have. You have 10 pounds per square foot. Okay, so the question is, what is that? Well, that's pressure. You have 2,500 cubic feet. All right, this is cube, so that has to be volume, and this is a distance measurement. Okay, so we've got pressure, we've got volume, no problem. We can figure out work. So we're going to take our pressure times our volume. All right, now one of the things that's interesting that happens here is when you look at the units. And pound is going to remain, as you can see here, but look at here. We had a square foot and we had a cubic foot, and now we're down to 1 foot. How's that? That's because this is in the denominator. So you really end up having a cubic foot over a square foot. They all cancel out but 1 foot in the numerator, and that's what you're left with. So it's 25,000 foot-pounds. Pretty easy. Okay, let's get into something a little more challenging for you. An underground pump lifts water 150 feet to the surface and into the top of a 600 cubic foot storage tank whose top is 40 feet above the surface of the ground. And just a reminder, the weight density of water, all right, is 62.4 pounds per cubic foot. What is the pressure? Okay, so to find the pressure in a tank, what you need to do is you need to know the height. Now this water is being pumped 150 feet to the surface and then 40 more feet. So it's a total of 190. That's why we're adding this. Then multiply it by the 62.4 pounds per cubic foot. Now that is the weight density specifically for water. If you were using something else, like let's say oil, all right, you would need the density weight specific for that oil. Okay. So anyway, when you multiply these two together, this is what you're going to get, 11,856 pounds per square foot. So you found the pressure. Now you can find the work. P times V, so you're going to take the pressure you found from in A, right here, and they gave you 600 cubic feet. That was your volume. You multiply those together, and you get 7,113,600 foot-pounds. All right, so makes sense. Okay, and example number 3. You have a pressure 50 psi is applied to a face of a hydraulic cylinder piston rod. Alright, the area of the piston is 0.25 square inches. The piston moves 45 inches. Now the key thing here is when you are finding the volume of the piston, it is a cylinder. Alright, and what they're telling you, this is the area of the end, or what they call the head of the piston. Alright, it is the end. It's the circular piece. Okay, that's your area. You multiply it by how long the piston is. Well, or in this case, it's going to be moving 45 inches. Okay, so how much is that space, that cylindrical space? So you can take the 0.25 square inches, multiply it by 45 inches, and here you get your volume. And then 0.25 cubic inches. So that's the whole space. It's round but long. Okay, that's a cylinder. That's what that whole space is. Okay, now, how much work is done when the piston moves? Well, it's going to be pressure, which they told us, 50 psi, multiplied by the volume you found, and you get 562.5 inch-pounds. Now, let's just say that you don't want inch-pounds. You need to have it in foot-pounds. You're going to do a conversion. All right, you're going to take that 562.5 inch-pounds, and the conversion you're going to use is 1 foot over 12 inches. Okay, the inches are going to cancel out. You're going to take 562.5 divided by 12, and you're going to be left with 46.9. The unit you're left with is foot-pounds. All right, well, that wraps up fluid work. It's a pretty short section. Make sure that you go over the examples. Primarily what you'll be asked is about open and closed systems and how to do some of the problems. Well, have a good week.